Game theory. Two countries, 1 and 2, can make abatement together or consider only their own net benefits. However, a mutual relation exists between the two countries. The matrix with coefficients showing the share of total abatement from a country that affects the other country is as follows. 1, 2, 1, 2, 0.6, 0.4, 0.7, 0.3. Okay, so what's going on here? Country 1's abatement affects itself to 60%, but 40% of its country 1's abatement affects country 2. So this is the abatement and this is the effects. Country 2's abatement affects country 1 to 70% and itself to only 30%. Okay, so country 2's is like upwind of country 1, and it's obviously pretty windy, so most of what country 2 does benefits country 1, not country 2 itself. And the damages are as follows. D1 is 0.6 A1 plus 0.7 A2. D2 is 0.4 A1 plus 0.3 A2. The values from abatement, I'm not quite sure what that is. The benefits, I guess, are V1 is 500 D1 minus 10 D1 squared. V2 500 D2 minus 10 D2 squared. So what is this? Okay, so we've got a kind of two-step function for determining damages. This is some kind of physical damages, I think, if I understand this question correctly. And then this is how that actually plays out in monetary terms. Okay. I think. Okay, yeah, because this is actually, these are damage reductions, aren't they? Yeah. Those are the reductions in damages, the physical damages. And then this is how these play out in terms of values. So this is really what we're interested in. And then we have these cost functions, C1 and C2. Okay. So, calculate the optimal allocation in the two countries when they cooperate. What do we mean by this? we basically mean, what would the social planner do? Okay, which is, the social planner is controlling behavior in both countries, and we're just looking to maximize the overall benefits. And of course then you might say, well, what about distribution? You know, how will the countries agree to this, and so on. Well, that's what we come to next. Okay. So now we're just trying to maximize net benefits, which are net benefits, let's call them N, are, it's like V1 plus V2 minus C1 minus C2, isn't it? Okay. I'm getting tired of writing out all this stuff, so I'm going to see if I can do this without writing out all the stuff. So we want to take first order conditions in A1 and A2, don't we? So let's take the first order condition in A1, which is then dV1 dA1, but V1 is a function of D1, isn't it? So dV1 dd1 dd1 dA1 plus dV2 dd2 dd2 dA1. Sorry. Yeah. dV2 dd2 dd2 dA1. You could also imagine dV1 dd2 dd2 dA1 and so on, but dV1 by dd2 is 0. dV2 by dd1 is also 0, so we don't need to bother with those. Minus dC1 dA1 and dC2 dA1 is also 0 equals 0, so we can write like that. Okay. I'm getting a bit tired. I've been at this all day. Right. dV1 by dd1 is 500 minus 20 d1, isn't it? And dd1 dA1 is 0.6 plus dV2 by dd2 is 500 minus 20 d2 times dd2 by dA1, which is 0.4, equals dC1 by dA1, which is 100 plus 30A1. Okay, and for A2, we're going to have something similar. For A2, it's going to be dV1 by dd1 dd1 dA2 plus dV2 by dd2 dd2 by dA2 should be equal to dC2 dA2. So then we get dV1 by dd1, 500 minus 20 d1 times dd1 by dA2 is 0.7. dV2 by dd2, 500 minus 20 d2 times dd2 by dA2, which is 0.3, equals dC2 by dA2, which is 50 plus 40A2. Okie doke. and I'm going to take a wee pause. Okay, wow. So we've got these two equations, and it's basically two equations in two unknowns, given this. But it's kind of messy, isn't it? Wow. I think what we can do to start with is turn these 20s into 10s. So let's go, instead of 0.6, we'll go 1.2, and we'll say 250 minus 10, and this will be 0.8, 250 minus 10. And here, this will be 1.4, 250 minus 10, and this will be 0.6, 250 minus 10. Okay, this is going to reduce my chances of making horrible errors, because these 10s are nice and straightforward, aren't they? So then we've got, going on the first one, we've got 1.2 times 250 minus 6a1 minus 7a2 plus 0.8 250 minus 4a1 minus 3a2 is 100 plus 30a1. So what have we got then? We've got 1.2 times 250 plus 0.8 times 250. So that's 500, isn't it? And then we've got 1.2, or 6 times 1.2, that's 7.2 a1. So that's minus a1 times 7.2 plus 4 8s are 36, 3.6 minus a2, 8.4, 3 times 0.8 is 2.4. Equals 100 plus 30a1. So 30, 40.8 a1 plus 10.8 a2 equals 400. Four eighths are 32, aren't they? So tricky here. Keep track of this. 40.4 a1 plus 10.8 a2 equals 400. If we did something similar with the second row, we would get, according to my crib sheet, 10.8 a1 plus 51.6 a2 equals 450. And now we've got two straightforward equations in two unknowns, and we can solve for a1 and a2, which are about 8 and 7, and the net benefits are 4 and 1034. Okie doke. Quick pause. Okay, let's see if we can get this one straight. So, just got to find the question. Calculate the optimal allocation was part A. That was this. Calculate net benefits, that was part B. That was that, which we just stick them back into the benefit functions here. So that is just really straightforward. Math, algebra, but then we want to move on to a non-cooperative situation. It's a bit unclear, perhaps, from the question, but in part C, we want to consider a sort of standard game theory setup where they're just thinking about themselves and treating the other players' actions as exogenous in a one-shot game. So we're looking for a Nash equilibrium where neither country regrets its choice given the exogenous choice of the other country. Okay. So we want to, for country I, we want to find the AI which maximizes that country's net benefits. VI of A1 and A2 minus CI of AI. Okay. So for country 1, first order condition in A1, okay, for country 1 is the V1 dA1 the V1 of A1 A2, yeah, given A2, how that changes with A1 must be equal to the C1 of A1, the A1. Okay? I think I'm getting this right. Let's see if this turns out right. The V1 by the A1 is actually the V1 d D1, which is 500 minus 20 D1 times the D1 by the A1, which is 0.6, equals the C1 by the A1, which is 100 plus 30 A1. And the other first order condition is going to be the V2 by the A2, which is the V2 by the D2, 500 minus 20 D2 times the D2 by the A2, which is 0.3, is equal to the C2 by the A2, which is 50 plus 40 A2. So those are our first order conditions. What do we do with them? So, what do we do with the first order conditions? Well, the Nash equilibrium is going to be a point where both of these first order conditions hold, right? So that is the no regrets situation, isn't it? So, let's do what we did before. 1.2, 250, 10, 0.6, 250, 10. And then we have 1.2 times 250 minus 6A1 minus 7A2 is 100 plus 30A1, and 0.6 times 250 minus 4A1 minus 3A2 is 50 plus 40A2. So, yeah, 1.2 times 250, a fifth of 250 is 50, so that's 300, minus 100 is 200, and then we're going to bring the stuff over here. 1.2 times 6 is 7.2, the 200 is 37.2, A1, 1.2 times 7 is 7, 8.4, plus 8.4, A2. Here we have 3/5 of 250, that's 150, minus 50 is 100, is 2.4 A1 plus 1.8 A2, 41.8 A2. Let me just check my crib sheet. Okay, so the crib sheet agrees with me. And we can straightforwardly solve this. It's a bit messy, of course, but then we end up with A1 is about 5, A2 is about 2, pi 1 is about 1160, pi 2 is about 1,000. So what's going on here? Well, basically country 2's abatement, as we talked about at the start, mainly benefits country 1 and not country 2. In first best, that doesn't affect things. Country 2 abates a lot anyway to help country 1, and doesn't get much benefit. In first best, country 2 cuts its abatement drastically. Sorry, in the Nash, country 2 cuts its abatement drastically and doesn't lose much benefit because it makes a lot of savings. Here, country 1 cuts its abatement somewhat and loses massively. And of course, totally, there's a big loss. If they could agree and have some kind of compensation scheme or whatever, they would be much better off. And that is always going to be the case by definition. And that is the end of that question.